Good morning, family and friends. My name is Mr. Mulenga, the teacher of science and mathematics at Our Lady School, Foxdale area in Osaka. Today, I want to discuss with you about an important topic in chemistry, and this topic is called periodic table. So, we'll be looking at what we call periodic table. Yeah, for those that do not know a periodic table looks like this. So this is a periodic table right over there. Now, by definition, what is a periodic table? A periodic table is a table of elements. This is a table of elements. It's a table of elements, but now what do you find on that table? You find the elements. Now, what pattern do they use to put these elements on the periodic table? They follow what we call atomic number. So what is a periodic table? A periodic table is a table of elements which are arranged in increasing atomic number. So I understand very well that everyone of you knows what an atomic number is. So the periodic table is a table of elements. These elements are arranged in increasing atomic number. Now, by the way, what is an atomic number? To start with, the atomic number is the number of protons that are contained in an element. That is a periodic table. So meaning the number of protons will determine the atomic number of an element. Now the number, the atomic number is what we'll be using to know how these elements are placed in on the periodic table. So what's the periodic table? It's a table of elements which are arranged in increasing atomic number. And what's atomic number? Atomic number is a number of protons that are contained in an element. So if that is what we'll be looking at today, so if you look at that periodic table, there are two important features that you find on the periodic table. There are two very important features that you find on the periodic table, and these features are: one is what we call period, two is what we call a group. So these are very important features that are found on the periodic table, and we'll be looking at them one after the other. So now we're going to start with a period. We're going to start with a period. What is a period? The period on the periodic table, this is the horizontal row. The periodic table of periods, these are horizontal rows that are found on the periodic table. So a period, one of the features that are found on the periodic table is a horizontal row that are found on the periodic table. So if you look at this periodic table, we are going to find these rows that are placed in a horizontal way. These are what we call periods. So if you can count with me, how many are they? You can count from here. We've got 1, 2, 3, 4, 5, 6, 7. We have 1, 2, 3, 4, 5, 6, and then the seventh one is this side. So there are 1, 2, 3, 4, 5, 6, 7. What can we say? We can say that there are 7 periods. There are 7 periods on the periodic table. There are 7 periods on the periodic table. So you can also counter check with me once again. How many are they? There are 1, 2, 3, 4, 5, 6, 7. There are 7 periods on the periodic table. But what information can we get from these periods? These periods are there to help us understand the number of shells that each element the number of shells that the electrons of an element can occupy. So we are saying from the period, this period is there to tell us the number of shells occupied. The number of shells occupied by electrons of an element. So I'll repeat that. Say the period is there to tell us the number of shells that are occupied by electrons of an element. So the first thing that maybe the good example that we can look at an element which is magnesium right over here. So if you look at magnesium, the good example is magnesium. Let's look at magnesium. How can we tell the number of shells that the electrons of magnesium are occupied so that we can depict the period in which the magnesium is? So if we pick magnesium, which on the periodic table is written Mg, the symbol of an element, and then the mass number is 24, the atomic number is 12. So if we are to write the configuration of magnesium, using these electrons which are 12, we're going to have the first shell will have 2 electrons, the second shell will have 8, that is 10, but they are 12, so we're going to have 2 more that are remaining. So from there we can see that the last shell has got 2 electrons, the middle shell has got 8, then the first one has got 2. So from here we can count how many shells. So if you have to count how many shells are occupied by electrons, you find that there are 3 shells. Therefore, this magnesium is in period 3. Let's counter check. So we're going to have the first shell here, the second shell is here, then the third shell, that's where we are likely to find the magnesium. It is because the 12 electrons of magnesium can only occupy 3 shells. Okay? So we can pick only another element. So that we tell if it is true, those elements that are found on those specific shells are determined by the number of shells that the electrons occupy. The other one that we can look at is we can look at phosphorus. So if this is the first example, the other one is phosphorus. Phosphorus, which is P. We have 31, then we have 15. So this phosphorus here, the number of electrons are 15. So let us see how many shells that these 15 electrons can occupy, so that we tell the shells the period where the phosphorus is found. So if you look at the phosphorus, which is 15 here, the first shell, according to Hans rule, states that the first shell can only occupy 2 electrons, and the reason is because this shell is so close to the nucleus and it is very small. Okay, so it can only occupy 2 electrons. Then there are 15. When we take away 2, we're going to remain with 13. The second shell can only occupy 8. So 2 plus 8. That is 10, but we are 15, meaning the last shell will have 3. So from here we can also say that how many shells are occupied by 15 electrons? There are 3. Therefore, this is in period 3. And let us counter check. You find that this phosphorus which is here, this phosphorus which is here, is found in period 3. The first period is here, we've got helium. The second period here, we've got nitrogen. Then the third one, that's where you find phosphorus. That is how we can confirm to say that the number of electrons that are in the element, the number of shells that are occupied by electrons that are in that element determine the period where it is found. Now, away from that, what other things can we learn about this period on the periodic table? The things that we can learn from there are the following. So we can look at what we call trends. Trends on the periodic table. So now these trends, we are talking about having this period, then moving from the left to the right. Okay. These are the periods: period 1, period 2, period 3, period 4, period 5. So now moving from the left to the right, what are the observations that you're likely to see within the elements? One, we can talk about the metallic nature. Now, moving from the left to the right, you find that the metallic nature of elements reduce. Moving from the left to the right, the metallic nature reduces. Left to the right. You find that, one, the metallic nature reduces. The reason is very simple, because we've got metals on the left. Then as you move from the left going to the right, what you find on the right are nanometals. That is number one. Then what is the other thing that we can look at from here that we can learn from it? We can also talk about the atomic number. You find that the atomic number is also increasing. You can check. We have helium here, whose atomic number is 2. We come here, lithium, atomic number 3. We have beryllium, atomic number 4. We have boron, atomic number 5. Carbon, atomic number 6. Nitrogen, atomic number 7. Oxygen, atomic number. So moving from the left going to the right, the atomic number increases. The atomic number increases. Okay? What other thing can you learn from it? We can also talk about the electronegativity. Now, what is the electronegativity? This is the ability that elements have to attract electrons towards themselves. So the electronegativity is the ability that these elements have to attract electrons towards themselves. So now moving from the left of the periodic table, going to the right, we find that the electronegativity of these elements on the periodic table increases. So the electronegativity increases. What does it mean? It means these elements that are on the left are unlikely to attract electrons towards themselves. What it means is that these elements that are on the right have the highest capability of attracting electrons towards themselves. So if you look at these elements that are in the second period, lithium and fluorine, you find that because lithium is on the right hand side of the periodic table, has got highest ability of attracting electrons towards itself. Therefore, fluorine is likely to receive electrons. That is the electronegativity. What other thing can we learn from there? Let's talk about the number of shells. The number of shells remain the same because we're talking about moving from lithium to a neon. We are in the same period, which is period 2. So moving from the left to the right, the number of shells do not increase. So the number of shells do not increase. The number of shells do not increase. Okay, then the other thing that you can also learn from the periodic table, remember we looked at two features. The first feature was the period, which we said this is the horizontal column, that the horizontal row that is found on the periodic table, and we said the period is there to tell us the number of shells that are occupied by the electrons of an element. The other feature which is very important on the periodic table is called the group. So if the period is a horizontal row, therefore the group is likely to be the vertical column of the periodic table. So if these are the horizontal rows, which are periods, therefore these lines here, which we call the vertical columns, are the ones that are there to define the period, the group, sorry. So what is a group? The group is these are vertical. Groups are vertical columns. These are vertical columns that are found only the periodic table. These are vertical columns that are found on the periodic table. Now, let's count. How many are there? Most of the times, the Examination Council of Zambia, the syllabus that we use in Zambia, we only deal with elements from 1 up to 8, mostly. So these elements that are here, which are called transition elements, are less talked about. Therefore, when you're counting the vertical columns, these ones here, we do not count them. Therefore, if you are to count, you're going to focus on these ones here, which is 1, 2. We're not going to count here. 3, 4, 5, 6, 7, 8. So we are going to say that there are eight groups on the periodic table. But in the actual sense, there are 18, except that these ones here, which are called transition elements, less talked about. Therefore, when you're counting the number of groups, we do not include them. And most of the times, many at times, these groups are written in Roman numerals. Written in Roman numerals. Okay, so what information do these groups carry? If we say the periods are there to tell us the number of shells that are occupied, what can we say about the groups? Groups are there to tell us they are there to tell us the number of electrons in the last shell. In the last shell, and these are called the outermost shells. So the groups are there to tell us the number of electrons in the outermost shells. So that means if an element has got one electron in the outermost shell, after writing the configuration, that element is likely to be put in group 1. So we are saying if an element is in group 1, if an element is in group 1, it is likely to have, it has one electron in the last shell. In the last shell, that is what it means. So let us try and see if this is true. We can pick on the same elements that we looked at, magnesium. Magnesium, which was written Mg2, 4, and 12. So now, if you do the configuration of magnesium with electrons, which are 12, you find that the first shell will have 2, the second shell will be 8, that is 10, but because they are 12, the last shell will have 2. So from here we can see that the number of electrons in the outermost shells are 2, therefore it is in group 2. But let us verify. So if this is group 1, this is group 2, this is group 3, group 4, group 5, group 6, group 7, group 8, so we are likely to find magnesium in group 2. And here we go, magnesium is in group 2. Let's look at the other one. Let's look at the other one. The other one that we can look at is aluminium. In which group is aluminium found? So the other one that we can look at is aluminium, which is written in Al 27 and 13. So if you do the configuration of aluminium 13, you find that the first shell will be 2, the second shell will be 8, and the third shell will be 3 because they are 13. So 2 plus 3 and 2 plus 8, that is 10, plus 3, that is 13. So how many electrons are there in the outermost shell? 3. So we're likely to find magnesium in group 3. Let us check. Group 1 here, group 2 here, group 3, and exactly that is where we are finding magnesium in group 3. So because there are 3 electrons in the outermost shell, therefore aluminium is in group 3. That is how we can tell the group where an element is found as well as the period. So if you are to include now the period here, we can tell how many shells are occupied by 13 electrons of aluminium, and these shells are 3. 1 first shell, 2, 3. So we are likely to see aluminium in period 3. If you are to come back to magnesium here, whose electrons occupy 3 shells, 1, 2, 3. So we are likely to see magnesium also in period 3, but in group 2 because there are 2 electrons in the outermost shell. Magnesium is likely to be in group 2 because there are 2 electrons in the outermost shell, and in period 3 because there are 3 shells that are occupied. So for today, that's where we end the lesson. But I'm going to attach the soft copy of the periodic table as well as the work that we're going to do. But make sure every work that is posted on this video, you have to answer with